named Jack Irwin. Independent mechanic, district registered, still running my shop out behind the dump called the Reclamation District. It's not much, but it's mine and it gets the job done. I watched last year's main division real close. Rylan Mercer put up a hell of a build. Didn't place, sure, but it had guts. That kind of work gets under your skin, makes you wonder if you've got it in you too. So this year, I'm ready to throw down in the CupCup Division. It's the lighter bracket, sure, but the Vanguard is still watching. They want something lean, mean, and built to survive a brawl in the back alleys of the Omniplex, and that's what I aim to give them. Things were getting out of hand in the shop. If I was going to take this RFP seriously, I needed to see the workbench again. I tore the whole place apart, cleared out scrap, sorted components, and even had to custom fit some brackets to keep the power running. I needed something quick, so I had them 3D printed. Clean, precise, and strong enough for the task. If you're looking for that kind of part, PCBWay is good for it. They're fast, reliable, and make sure your parts get made to spec. PCBWay offers advanced 3D printing, PCB prototyping, and manufacturing services, making it easy to create custom, intricate components, whether you just need some brackets or you're working on the next articulating mech design. Speaking of mech designs, I could finally think straight with the shop back in order. This year's CupCup calls for repurposed components. A spherical core and a standard container element are mandatory. The sphere requirement had me stumped at first, but while digging through archived data, I came across something buried in ancient warfare records, a turret system called the Sperry ball turret. Compact, mobile, armored, not bad for a gunner's coffin. Around the same time, I stumbled onto the work of a conceptual engineer named Brian Penkwitz. His schematics stood out immediately. Thoughtful designs, functional lines, nothing wasted. I reached out, pitched the CupCup challenge, and asked if he'd be interested in a collaboration. Brian sent over some preliminary designs, and after a bit of back and forth, we agreed on a chicken walker configuration. Strong stance, good field visibility, stable recoil platform, and his input has been invaluable. Huge thanks to Brian for lending me his time and talent to this project. His contact details are included in the audit description. The CupCup's got a size limit, so I'll need to scale Brian's designs to fit it. Problem is, the required sphere can't be scaled, so the rest of the chassis is going to have to work around it. To help keep things straight, I'll include some highlighted schematics, since it gets pretty disorienting when you're trying to follow which parts bolt onto what. We'll start with the upper body first. For the cockpit walls, I repurposed part of a clinical retention cell. They're pressure-sealed, chemically inert, and built to hold, well, biological material. Long-term storage or cloning or something, I can't remember. Not usually found in a mechanic's inventory, but you don't need to worry about that. It fit the dimensions, and it passed stress testing, so I'm using it. Once I had the retention cell cut and sealed, I mounted the turret using a segmented magnetic capture ring. It's not a full gimbal assembly, but the magnets hold the sphere firmly while still allowing it to pivot freely inside the housing. No rails, no bearing tracks, just field tension and careful alignment. I tuned the spacing until the motion felt smooth but locked in when idle. It's simple, clean, and easy to service if something binds up. Good enough for Vanguard spec as far as I'm concerned. I machined a simple frame to give the cockpit a flat mounting surface, then shifted focus to the ball turret assembly. Historical records show plenty of flaws in the original ball turret design, which I'll address, but personally, I just hate machining spherical surfaces. The waist assembly is built from standard hardware most of you probably recognize. I had to go with an off-brand version, but it holds up fine. Honestly, performs better than I figured it would. To avoid turning the medical container into my own version of a gunner's coffin, I need to add more armor to the design. A reinforced top plate helps deflect overhead fire, especially during aerial bombardment, and I mounted it using a pair of angled side braces. Attaching anything directly to a curved surface like that isn't ideal. Cylinders aren't much easier to work with than spheres. Once it's seated properly and locked in, the top armor doesn't just act protection, it also doubles as a potential mounting point for future upgrades. If the Vanguard wants to bolt something else on later, they'll have the space for it. I added a reinforced mesh panel to the back of the cockpit. This acts as a heat sink for the engine block, and it doubles as a Faraday cage in case of a localized EMP discharge. It keeps the pilot cool and conscious. The torso sides are simple blocks, with just enough space to run internal systems and give the rockets somewhere stable to bolt on. Brian worked in a pair of forward-mounted stabilizers on either side of the cockpit, part of an emergency tilt correction system. If the frame takes a hard hit or it needs to jettison the pilot fast, these pistons shift the cockpit just enough to compensate for catastrophic misalignment. It's a clever solution, and I'm implementing it as drawn. Might not be standard, but I've seen worse ideas get pilots home. As mentioned, the original ball turret had its share of problems. High fatality rates, poor placement, and limited visibility to name a few. Ours isn't bottom-mounted, but visibility is still a concern. Armor and guns block your line of sight no matter how far you rotate. Fortunately, we've got sensors, cameras, and assisted targeting now, so mounting sensors just below the turret should give us coverage without blinding the operator. The engine's nothing special, just a standard twin-stack biodiesel unit I had in storage, buried behind some medical stuff. Since this mech's on the smaller side, I cut the exhaust down to something less obnoxious. The Dominion's reuse mandate encourages using what still works, and my budget makes sure I stick to that. These engines are common, reliable, and easy to integrate, though I wish they didn't smell like burnt fertilizer when they're running hot. Rocket mounts need elevation control, so I used car-sized servos. Mounting holes were cut into the cockpit sides to seat the gearboxes behind the armor. Brian incorporated independent targeting sensors per rocket launcher, which meant I had to be a little more careful with the install than usual. I started pulling the components out of storage, still sealed surprisingly, and seated each one in a bit of putty to keep the alignment dead on. Once I had the angle locked in, I welded the forward sensor to the housing, then closed it off with a metal shroud I cut to size. After that, I had to modify one of the signal dampers, an old ceramic tension rod, and thread it into the housing without snapping the leads. Those wires are finer than thread and don't like to cooperate. Once it was wired up, I mounted the whole thing to the top of the launcher bracket. Electricals ran back to a terminal block behind the engine. I routed a line forward first to power the stabilizer pistons, figured since I was already there. Then I looped back to finish the rocket sensors. Bending the conduit to shape took longer than I'd admit, but now the system synced in firing clean. With all of the electrical work finished, I finally installed an antenna at a very low angle, due to the CupCup size restriction. The Dominion-issued sphere is surprisingly cheap, which is probably why we have to use it, so I'm repurposing one as a mold. I'll admit, shaping glass into a turret isn't my specialty, but I'm not cutting flat windows into a sphere, and I'm not using 2-inch slabs like the original. With a photonic kiln, I can cast impact-rated glass to any spec, so I'm making it as thick as I can without throwing off the balance. Remember when I said I hate sphere work? Well, I ended up making another one. Brian's original design included side windows, which sounds great on paper, but this is where I drew the line on fabrication complexity. Sorry, Brian, but not sorry. I simplified it with a more armored shell, and once the main viewport was in, I could weld the turret shut solid. The original ball turret ran twin 50 cals, and honestly, I've got no complaints there. For urban combat, especially against gang elements like that ash chain brawler that hit the feeds last month, This offers plenty of ballistic output. If it's not enough, that's what the rockets are for. Anything heavier would just waste weight and ammo against soft targets that don't justify mech-grade overkill. Speaking of mech-grade overkill, rockets. Sure, missiles are smarter, but in urban combat, there's no range to justify onboard guidance. These are second-hand pods, probably ORG scrap from a Volt trial. I added a backblast redirect shield to keep from torching nearby walls or allies. Tight quarters means friendly fire's a lot more literal than usual. Working top to bottom, the next section is the pelvis. Since the torso's focused on the pilot, Ryan concentrated most of the hardware down here. Denser systems, heavier components, and extra armor to keep it all protected. Starting with a plasma torch, I machined out matching holes on either side of the pelvis for the hip connections. They needed to be wide enough for internal system routing and strong enough to carry the full weight of the chassis. I used hollow mounting fixtures, internally open for cable feeds, externally threaded so they could clamp to the surface. Just temporary during test fitting, but they held steady. The hex-shaped sockets had to be chipped by hand until the bushings seated snug and aligned cleanly for welding. The waist platform on top of the pelvis matches the one mounted beneath the torso. Using identical components for both mating surfaces makes alignment straightforward and ensures functional consistency. The pelvis needed a full seal, so it took more effort than the torso. I cut a front plate slightly oversized and welded it in, leaving a lip that I could grind back flush. That's far easier than trying to hit a perfect cut and weld alignment on the first try. I asked Brian for details on the pelvis rear, and he said the design will need an air intake for cooling. After mounting the prefab cooling unit, I spotted these corner bumpers, small by mech standards, though still about head-sized. They're a smart addition, meant to shield wiring and nearby systems from impact damage during tight maneuvers or rough terrain contact. Subtle, but practical. Even with added armor here and there, the mech stays relatively lightweight, something I want to preserve for maneuverability. That said, this front armor plate is a solid exception. It's a heavy defensive slab right over key systems, letting the unit stay operational longer and push forward under fire. The angled side wings at the front are a clever addition. They increase the chance of frontal shots deflecting, though on a bot of this proportion, that could mean rounds bouncing right into the hips. Thankfully, Brian thought ahead, and he added thigh armor to catch anything that glances across. I made both wings identical, then taped them into position to act as a temporary hinge. That helped line up a sort of mitered joint. Small alignment wedges were welded onto the front plate, then used to lock the wings in. Once assembled, the whole unit mounts to the pelvis. Even with the cooling unit mounted at the rear, the system still needs additional vents. Right behind the front armor plate is a well-protected spot for them. Air cooling works best with both intake and outtake paths, letting fresh air flow through, absorb heat, and exit cleanly. Same principle as keeping a personal computer from frying itself. Cooling at the front of the pelvis is finished by adding 2 matching vents to either side of the armor plate. With that in place, I can start wiring things up. Bending conduit isn't the hardest task, but it's easy to mess up if you ignore the bend radius. Every material shifts slightly as it curves, offsetting your end point. Know your material or check the machinist's handbook, and you can adjust. Just apply steady pressure and keep those corners tight. In my experience, installing the conduit is usually harder than shaping it. Depending on the junction angles and spacing, it can be a nightmare. You can pivot and tuck things cleverly with the right fittings, sure, but I don't usually plan that far ahead. I just force it into place and hope that it holds. Thankfully, Brian included retention brackets on the pelvis. They weren't really needed on the torso, but here they help keep the wiring tucked neatly in the gap between the pelvis and the waist. I mounted a pair of electrical junction boxes behind the hips, mirrored units, each one capable of taking over if the other side gets knocked out. It's an old design principle from pre-Dominion flight systems. Split control logic with full bilateral redundancy. Most of the time was again spent bending conduit to fit, then running the wires to link cooling, power, and the front panel connection. Everything synced up clean. I nearly overlooked this, a small linear damper tucked behind the front armor. It's a clever application. Instead of controlling motion, it's positioned to absorb impact vibrations and reduce stress from incoming fire. The front panel is a kinetic impact sensor, wired to the internal shock dampers. It reads hits in real time to reduce stress. It might get blown off, but it's thick enough to do the job, I think. Last up were the legs. I started with the heels, then moved on to the foot pads, and it ended up taking more time than I expected. If you've never built a leg before, they're more complicated than they look. Standing, balancing, and managing weight isn't just a matter of bolting on joints and hoping for the best. It's especially a bummer when you think you can use the easy tool only for your parts to explode. After pulling out the difficult, dangerous, loud tool, I was able to get the foot pad into the shape I wanted. Manual shaping was still necessary. The original Mecha Contest, and the CupCup Division by extension, allows up to 15% of the build to use newly manufactured, computer-aided parts. I needed that margin for the joints. I managed to source some entry-level Volt components from the Dominion's modular frame initiative. That gave me a solid foundation to work from. It was still a tough build, but definitely less painful than starting from nothing. When building a machine with this level of precision, it's always worth remembering that a good shim can solve a bad fit. Since the legs function as one continuous kinetic chain, I moved straight on to the thighs. Personally, I don't find it practical to finish the shin completely and then try to match the thigh afterward. Instead, I prefer to start with the critical dimensions in place, get those measurements locked in first, then build up the rest of the subassembly around them. It saves time, avoids rework, and it helps keep alignment tighter across the entire leg structure. The shin armor came from a salvaged menthol pellet flask. Not sure what was actually in it, but it's symmetrical, which means I could split it and get 2 mirrored plates for each leg. That's not strictly necessary, but I like keeping things consistent when I can. The material responds well to the ultrasonic cutter. After rough sawing it in half, I trimmed away each side slowly until they seated clean against the shin frame without binding any of the joints. I haven't messed with spring-loaded shock absorbers in a while, so I figured it was time to tackle that next. With the leg frame already roughed in from hip to heel, it's mostly about picking your poison and working through it one section at a time. I started at the back of the shin, installing a pair of vertical shock units just above the heel plate. These aren't active dampers, just mechanical springs with compression limiters, designed to take the edge off during hard landings or sudden stops. Getting the ankle right took a bit of trial and error, since the mounting points need to line up under full compression. Once both sides were locked in, I ran a few test flexes, and they held up fine. After proudly claiming that the shin armor cleared all of the joints, I realized I'd sealed the neath shut. I cut access with a plasma torch and cleaned it up with a rotary tool. That let me install the pivot pin, cover, and bearing assembly. I also borrowed an idea from the Ash Chain gang. Disc brakes inside of the hip joint for better motion control under load, and it actually works. The thighs had a frame, but they didn't have a proper shell for internal systems. I'll admit, I cheaped out and ordered a custom cover from Fast Draft Machining to fit over the brake assembly. Still, I made up for it with plenty of cutting, grinding, and shaping to finish the rest of the thigh housing by hand. The outer faces of the thighs are packed with subsystems, which meant I couldn't just slap on flat armor and grind the lip down like I did with the pelvis. I had to cut a set of carefully shaped panels, each tailored to specific mounting points and internal clearances, ensuring everything fits securely while still being accessible. The loose shock absorbers kept catching my eye, so I added a rear calf panel to lock them in. It cuts down on movement and keeps them from falling out mid-assembly, so I could focus on the thighs. It took more effort than expected, but layering filler and grinding the thigh seams repeatedly gave me a much cleaner finish in the end. Brian incorporated a radial compression lock into the knee joint, designed to press inward from the sides to control motion. I shaped the block to match the joint's curvature and installed it along the midline for balanced braking. I reused the photosensitive polymer from the ball turret to bulk up the thigh armor, which let me countersink the compression lock. I then spent several lifetimes grinding it flat. Speaking of lifetimes, this audit's been going on for a while, longer than I expected to be honest, and we're still not done. If you stuck with me this far, congratulations. You're either part machine or just very, very patient. Either way, I figure we've both earned a bit of a break from the non-stop technical rundown. At this point, most of the structure's in place, and if you need the fine details on this section, feel free to study the visuals. Every weld, plate, and shim is right there on the screen. Now, here's the truth of it. I won't be finishing the paint job or final testing for a little while. I've been pulled for reassignment. My turn to take one of those mandatory decompression cycles that the Dominion insists we all schedule. You don't argue with a higher-up when they tell you to clock out. You just clean up your bench and pretend to enjoy the sun. So, this is a working audit, not a completed one. A Part 1 finish pass. Everything's built, everything fits, but the polish will have to wait until I'm back in the shop. It shouldn't take too long. I've already got a few ideas for the livery once I can get my hands back on the frame. On a slightly different note, word's gotten around that someone up the ladder is paying attention to this build. Not sure who, not sure why, honestly I don't really care. I'm just a guy with a cluttered bench and a borrowed work permit. But I've been doing this long enough to know when to double check my welds and tighten every bolt twice, just in case. And before I forget, CupCup entries need a name. It's actually a requirement for the contest. Can't just call it the build forever. I've been leaning towards the name Talon. Feels right. It's a grounded thing, sure. It walks instead of flies. But it's sharp where it counts, and it keeps its head on a swivel. Fits the design. Still, if you've got a better idea, I'm all ears. Dominion says feedback builds a better machine. Not that they ever take it. I know I gripe about the Dominion sometimes, and we probably all have, but all things considered, they've built a system that works. Power's stable, water's clean, and I haven't paid a single credit for medical treatment in my entire life. Crime's low in the regulated zones, and if you follow the rules, you get left alone. That's more than I can say for the outer sectors. I've seen what freedom looks like out there. Burned out settlements and scrap markets selling expired nutrient paste. I'll take structure over chaos any day, especially when the Vanguard's mechs are walking on my side of the barricade. Thanks for sticking through the grind, and a big thanks to Brian Penkwitz for the concept art. This mech would not exist without his input. Not sure why this one took so long, maybe just too much to document, but either way, part 2 brings the finish. Paint, testing, and whatever else the Dominion Vanguard asks for. I'll see you then. For you scribes at the archive, outtakes are at the end. Don't say I ever held back data. Oh, wait, hold on a sec. I totally forgot. Let me just get this replaced with a new turntable And let's get the Dominion insignia in here and... Same principle as something. What am I thinking? Where am I reading? As mentioned, the original ball turret had its share of problems. High fatality is not the word. High fatality rates. High fatality rates. As mentioned, the original ball turret had high fatality rates. So mounting weapons just below the turret should give a mounting weapons. Sensors. The front panel's a kinetic impact sensor. The front panel's a kinetic impact sensor. The front panel's a kinetic impact sensor. The front panel's a kinetic impact sensor wired to the internal shock dampers. I was so focused on kinetic impact.